Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over the spread syntax or the spread operator in JavaScript. Now, this video, as well as a few coming up where we're going to go over some other types of syntax, are going over some newer types of syntax in the language. These things are actually not necessarily net new things that we're going to kind of add to our abilities per se, because we can actually do all these things with the existing syntax that we've already learned so far up until this point in this series. However, that said, these new bits of syntax were added just to make the developer experience much more ergonomic, much easier to use, much more kind of fun code to write. A lot of these things have been added to the language as a result of kind of some frustrations and repetitive code and things like that. So it's really useful to kind of learn these new concepts, and we're going to start with the spread syntax. So that said, let's get right into it. So to start, I just want to do a recap on this concept of iterables. So in the for of loop video, we actually saw that iterables are these things that we can kind of like loop over. They're these collections of things, right? So we went through kind of the idea of strings, arrays, maps, and sets. And I mentioned that there are other things that are iterables as well, like generators, for example, which we'll look at in a future video. And we can even build our own custom iterables as well. So just keep this in the back of your mind, specifically things like how a for of loop might work, because we're actually going to see examples of how that works in future videos as well with this idea of iterables. So for the spread syntax, we need this idea of iterables because we're actually going to use this new spread operator in order to achieve kind of what's called copying or spreading out these different iterable objects into either arrays or objects. Okay, we're going to go over these two in this video because that's kind of like 95% or higher of the use cases. Technically, we can actually spread out function arguments as well. However, that kind of just lends off of this idea of array iterables and spread operator as well. So when we actually do need to use that, which is not as often, it'll kind of just make sense intuitively because we already know the concept. So without further ado, what is this actual spread operator going to offer us? So take a look at this. This is kind of how the spread operator works. So this is working with arrays. Imagine that we have this array right here. So we're pointing prices at this array of 5 numbers. If we wanted to create a copy of this prices array, we can kind of do that using many ways that we know of so far, for example, loops, right? However, with the spread operator, we can actually just do this, right? We can do a array syntax, and then inside of the array, we can like spread out the values from an iterable object, in this case, an array, one at a time into that kind of outer array. So here we're saying spread out the values inside of prices, which should be an iterator, and in this case it is because it's an array, into this outer array. So we're actually going to get a direct copy of prices. So this copy is going to be 10, 20, 30, 40, 50 inside of an array. Okay, so let's just take a look at that in code just so that it makes a little bit more sense. And I'll show you kind of the previous version if we didn't have spread and the version with spread as well. So I'm just going to do intro.js for this file here, and I'm just going to create an array. So I'll say const array. Can't be too creative right now for numbers for some reason. Let's just go with that example, 10, 20, 30, 40, and 50. Okay, so if I want to actually create a copy, so I'm going to say this, const array copy 1. What I could do is just create a regular array like this. So this is the syntax that we would use if we didn't have the spread operator. Now there's many ways to actually loop through an array. I'm just going to go with one version that we've learned recently that's a little bit easier. So I'll say for const value of our original array. What we want to do is we want to say array copy 1, dot push, right? And then we want to push that value. And then if I console.log out the array copy 1, as well as technically our array as well, then what we'll see is that these are going to have the exact same values inside of them. So if I make sure I'm in the correct folder, I run node intro.js, and you can see that we have 2 of the exact same array. And I can prove that these are actually copies of each other. So if I change one, the other is not going to change by, for example, if I say array1 copy dot push and I add 60 to it, I am adding it only to array copy. I'm not adding it to array. So if I run this, what we'll see is that array1 copy is actually going to have that added value, and we never actually changed the initial array, the original array, which is called array in this case. Okay. Now what we can also do is we can say const array copy, and I'll just say 2 just for sake of example here. And we can use that spread operator, which is the ... Now this has to be used inside of square brackets for an array or inside of curly brackets, which we'll see later, for the object syntax. So in here, we're saying what values do we want to kind of loop over and then put into this array? And we want to copy array. So what this is basically doing right here is looping over this value, which is an iterable, in this case an array, and then putting them into this kind of resulting array. So you can think of it as doing exactly these steps, creating this array, looping over all the values inside of the thing, and then eventually we're going to have a copy, which is going to be kind of what we're seeing over here. Okay, so if I console.log out my array copy2, what we'll see is that this is going to have the same values as our first array. All right, perfect. So hopefully that makes sense. Let's keep going with this. So the nice thing about this is you're probably thinking, okay, like this doesn't really save us this much effort, right? If you look at this syntax, we start to get into interesting situations, okay? Here we have the same array, right? 10, 20, 30, 40, 50. And here we're saying we want a new prices array, which is going to be using the spread syntax to spread out the original prices, but it looks like we're actually adding some values here at the end. So what this is technically doing is very similar to what we just saw, and then pushing 60, 70, and 80 onto the copied array and not changing the prices array, which is the original one. So what we see is prices, new prices, sorry, is going to be all the way up to 80, but prices in this case is going to remain at 50. The nice thing about this is that we can add values kind of before the spread or after the spread, and then we can kind of intertwine these together to make kind of very concise syntax, right? So if we were to do that, for example, if I want to push, like, let's say 70 and 80 here, right? If you were to compare kind of, if I even just get rid of all the spaces, right? And I compare that line to, let's just say 60, 70, and 80 here, right? What we've achieved here in several lines, right, with this lines 3 to 9, we're actually kind of doing in line here on line 14. So these things are doing the exact same operation, but hopefully you can kind of see that actually, in my opinion, not only is this actually easier to read, but it's also much, much shorter, right? The chance of us also making a mistake is much less just because of the amount of code that we're writing is also much less, and it's just more intuitive. We're saying kind of copy all the stuff from array and then just add these extra 3 values at the end. I can also add them at the beginning, right? So if I say 10, 20 like this, and then I log this out, what we'll see is that we have 10, 20, and then 10, 20, 30 again, and then all the way up to 80. Okay, so very, very concise, neat syntax, really, really helps a lot. We're going to be using this pretty much everywhere throughout our programs, hence why we're going through this in a separate video. Okay, so I mentioned that this works with iterables. So a string also is an iterable. Right? So let's look at this example together. Here we have greeting, which is pointing to the string bonjour, right? And then we have a new greeting variable, and it's spreading out the greeting, but then it's also adding kind of exclamation points at the beginning and then at the end, right? So what we're actually going to get here is this array of characters, or technically strings. Right? We're going to have an array of every single letter inside of bonjour split up, as well as those kind of exclamation points or bang symbols at the end and at the beginning. Okay, so let's take a look at this. I'm just going to call this strings.js, and I'm going to say const phrase equals hello, my friend. Let's make this nice and big. I'll put an exclamation there as well. And I'll say const copy is equal to, let's just say, oh my gosh, phrase, just like that. Okay, so notice that I'm kind of spreading out this string into an array, right? So what this is doing is looping through the string and adding each character into this array. So if I run node and then my strings file, of course I didn't print it out. If I log out copy, what we'll see is that it's kind of an array of every single character in that string split up, which is really, really nice. Now, there's of course other ways to do this with strings and arrays. However, this is quite kind of a neat operation that we can do. So for example, we can even add values at the beginning and at the end if we wanted to, just like I had in the example earlier. This is just to show that this really does work with iterables. It's not only with arrays. So that said, another iterable that we looked at recently was the set. Now, the set was a way to kind of use an kind of array syntax almost, but without any duplicate values. So everything in a set had to be unique. And we have a previous video looking at sets in quite an amount of detail if you haven't seen them before. So in this case, we're creating a new set called ages. We're adding these numbers to the set 5, 10, and 15. And what we can do is we can even spread out the set and add new values to it inside of an array. All right. And this, in this case, would be an array of the values 5, 10, 15, and 20. So let's take a quick look at that just for sake of example. So we'll do sets.js and I'll say const my set is equal to a new set. And then I'll add some kind of strings to the set. So I'll just say my set.add, and let's go with add Batman. Let's add Robin, and let's also let's add Spider-Man, right? And I'm going to also add, let's go with Batman one more time. Okay, so Batman's going to be ignored, right? Step 6 is actually going to be ignored because sets don't allow duplicate values. So if I console.log this just to prove that my set, and then I do node sets.js, what we'll see is we have a set of only Batman, Robin, and Spider-Man, right? We do not have two Batmans in our set. There is only one Batman, okay? So to spread this out, we can say my set, let's just say copy is equal to, and then we can use array syntax again, and we'll spread out my set, and we'll get an array of the values inside of the set. Okay, so if I console.log out my set copy, technically it's not really a copy because now it's an array, it's no longer a set, but let's take a look at what we get. So you can see that my set is still a set, right? It's just a set of 3 items. But now we've converted it into an array of those 3 items, right? By spreading out all those values from the set into an array. Now that comes with the caveat that this is no longer a set, right? So if I wanted to add, say, Batman in here again, right? This is totally fine, right? Because we no longer are working with a set, we're just working with an array, and an array is allowed to have duplicates. So if I run this, you'll see that now here we do have Batman twice, right? And then I can add things in the beginning here. I can say Robin, for example, and in this case, we'll have all of those values added to our array. Cool. Hopefully that helps and makes a bit of sense. Now, the last one I kind of want to show you before we get to objects, which is quite a bit different, is just maps. So we saw again in the previous video where we kind of looked at maps compared to sets, that maps are very similar to objects, but they kind of have some interesting properties and a nice API to work with. So for example, in this case, we're creating a new map and we're pointing stock at that map. And you can see I forgot to rename these variables here. These should all be stock, just so that we don't get too confused. Let me just quickly change that for us. And what we're going to see is we're adding 3 values to our stock map, right? We're adding apples with the value of 3, mangoes with the value of 20, and bananas with the value of 7. All right. So you can think of it as very similar to an object. However, there are some differences that we went through in the map video together. But since a map is an iterable, we can actually spread it out. Right? We can take everything inside of map and spread it into an array. So this might be curious, right? Because like, what do we actually get when we have kind of 2 values that we need to spread into an array, right? Do they kind of just get clumped together, or what do we end up with in this case? So let's take a look here. if we do this, we'll actually get this array right here, which is an array of arrays, where each inner array is actually the key value pair of that resulting value from the map. So for example, when we take apples of 3 and we put it into the spread operator for the array, we get this item right here, which is an array with the key first and the value second. Okay, it's always in that order, and this is going to become very important as we actually work with an idea called destructuring, for example, in the following videos as well, because things always come as key value pairs. So you can kind of see how if we were to kind of loop through this and add those key value pairs as arrays, we would kind of arrive at this array of arrays with the key value pairs that looks like this. So let me go ahead and really create a new file real quick. I'll just call it maps.js. I'll just say const my map is equal to a new map. And I'll say my map dot set. I always mix up the API with sets and maps. And then let's just say that we want to add animals here for whatever reason. Let's just say you have a bunch of animals in your jungle. If you do have a jungle, I have, let's say, a bunch of monkeys in there, my absolute favorite animals. Let's just say we have a bunch of tigers in there, maybe only one tiger if monkeys would get kind of scared, and maybe we'll have, I don't know, an elephant, right? And we can maybe have 2 of these elephants, okay? So we're gonna set our map up to have kind of these key value pairs inside of it. So if we were to print this out and I log out my map, let's take a look at what we get. So I'll run node my maps.js, and you can see that Node.js actually neatly kind of prints this out for us. We have 3 items in our map, and then monkey's value is 5, tiger's value is 1, and elephant's value is 2. All right, so if we wanted to kind of spread this into an array, we'll say my map array is equal to an array syntax, and then we want to spread out my map, okay? And what we can do is we can also add values to the end. So for example, if I just added boo to the end of this array, let's see what happens. So I'm going to console.log out my map array and run this again. And you can see that this is the array that we get. So we kind of get those key value pairs, right, as arrays, right? Monkey of 5, tiger of 1, elephant of 2, but then I've added this string instead of an array to the end of an array. Now, this is not really ideal. I do not recommend you do this. I'm just showing you this for sake of example, because this actually does happen in kind of real life as we're programming our apps, and we kind of try to mix and match things inside of arrays by accident. And in this case, if we were trying looping through this array and expected every item to be an array, we might run into issues because this last item is a string and not an array. So maybe our program would crash if we're not handling errors correctly. So this actually does happen quite often, hence why I want to show it to you here, just so you can see one example. And we'll go into more examples in the exercises together. Okay, wonderful. So that kind of covers array spreading, right? So hopefully you can kind of see with those examples, right, where we kind of looked at maps, we looked at sets, we looked at strings, and then we looked at just a kind of vanilla array. We can kind of make copies of these things, but in the context of an array as a result, where we spread those value out into an array. Now, I mentioned at the beginning that we had this other use of an object literal, right? We can spread objects into an object, and it's quite different from spreading into an array. So what does that look like? Here we have what kind of that might look like, right? Now there's a lot of code here, so let's go through this kind of a bit slowly together, and we'll actually code it out as well. So let's pretend that we have this variable pointing to this object, in this case, country populations. So let's just say that we have in millions, let's say we have Germany of 83, Brazil of 212, and then Egypt of 102. Okay. If we wanted to create a copy of this object, right, we could actually use the same spread operator to do that, which is actually pretty amazing. Okay, so what does that look like? It looks like this right here. I'm creating another variable called country pop extended, and I'm pointing it to this object, right? Because I'm creating a new object with the curly brackets. And what I'm doing here is kind of the most important part. I'm spreading out the keys and the values from country pop into this new object. And I'm even just adding some new key value pairs after I spread out those values. So what we actually end up with in this case is this object down here with not only our original Germany, Brazil, and Egypt, but we end up with Indonesia and Japan in there as well with their respective values. And then this country pop extended is actually a copy of this object right here. So if we were to change this object, we would actually not make any changes to this object right here. Okay, and we'll see some caveats with this in a second. So let's take a look at that. We'll just say objects.js for a new file here. Let me close this off. And I'll say const, let's go with kind of this example right here, just so that we can actually add to it country pop, and we'll say Germany, and we said Germany was 83, and then we'll say Brazil, and Brazil was, sorry, all flipping back and forth, lots of white and dark, and Egypt is 102. I believe these are from maybe even just a couple years ago, might have changed by now. So this is an object, right? If we console.log out country pop, what we'll see is node objects.js. This is a kind of vanilla JavaScript object, right? We have keys and values. This is different from a map. This is just using the built-in object type inside of JavaScript, which is the curly brackets. Now, let's say I wanted to create a variable called country pop extended. Okay, let's do that. I'll say const country pop extended. And this is going to equal to an object. Okay. How would we take all of the key value pairs inside of pop and then add them to country pop extended? Right. So the easiest thing to do would probably be to kind of loop over everything inside of country pop and then add it to country pop extended. Okay. So there are a couple of ways to do that with objects. Technically, we can do a for of loop. So I can say for const, and then I can say something like entry of object.entries, and we covered this in the object video, country pop. So this is going to give us back an array of key value pairs inside of the object country pop. Okay, so if I say console.log out that entry, just so you can see what this looks like, just so it makes a bit more sense, we're actually going to get back this array where the first item is the key and the second item is the value. So that's what's happening here on line 12, is these three lines right here. So I can say const country is equal to entry at 0. And we're going to see a shorter syntax for this in the destructuring video as well. And we're going to say const pop is equal to entry at 1. So we're pulling out these two values, right? This is array at 0 and this is array at 1. So country and then the population. And then what we can do is we can set country pop extended's key to the country and then the value to the population. So we can say country pop extended and we can do at the country, right? At that key is equal to that population, right? So we're saying set the Germany key to 83, set the Brazil key to 212, right? So now if I console.log out country pop extended, what we should see is a direct copy of this object, okay? And we do, right? And then if we want to kind of go ahead and do this thing where we're adding Indonesia, for example, and Japan, what we'd have to do is we'd have to kind of do that after the fact. So we'll say country pop extended at Indonesia is equal to, what was it? 273, right? And we could do the same. We could say Japan is 125. Okay, and if we do this, we'll see that we have the new object here with those new key value pairs inside of it. Now, hopefully you can kind of start to see, just like with the array example, right? If I kind of even make this with no spacing at all, right? And I just cram all this code together, this is quite a bit of code, right? Just to copy an object over and then add to new values, right? It's just like, okay, like, you know, you kind of have to know how this for of loop works, the entries, like got to figure that out, maybe look at NDN or something. Then you kind of have to get the key and the value, you know, set it together. It's just a lot of work, right? All I want to do is copy this object, right? So if we wanted to create another copy, so I'll just say const country pop extended to, check this out, right? The spread operator I'm just going to spread this up into multiple lines just for sake of kind of neatness and examples, but you can do this in one line or many. Traditionally, you'll see multiple lines. We can spread out everything inside of country pop. This single line technically right here, where we're spreading out everything inside of country pop, is effectively doing this right here, where it's looping through country pop's entries and adding each of the property value pairs or key value pairs into country pop extended 2. We can even go one step further and kind of set these other values of Indonesia right here. And we could say Indonesia is going to be 273. And we can even add Japan, and Japan is going to be 125. Okay, so we're saying spread out these values from the original country pop, and then you can add these new key value pairs. You can see that it removed my quotes because technically we don't need quotes for object keys if they're just one word. So in this case, this syntax, even though it's spread onto multiple lines, is just so much easier to read and understand than this syntax right here, even though they do exactly the same thing. And that's what I meant at the beginning of the video. We have the tools to do this manually, and it's important to know how to do this manually yourself in order to actually understand what these new pieces of syntax actually give us as a benefit, and that they're actually built upon something. However, once you understand that, it's definitely much easier, more readable, easier on your teammates, coworkers, friends' eyes to actually read syntax that looks like this than it is to kind of work with something as cumbersome as this, because this is even a little bit error prone and you might even run into bugs, but it's much easier or less likely that you're going to run into bugs this way with the spread syntax. Okay. Whew, quite a lot of stuff there. So I just want to show you one kind of interesting thing with objects. With objects, it turns out that you can actually kind of overwrite values when you're using spread. So let's take a look at this example together. Imagine that we have the same country pop object and we spread out country pop, and instead of adding Japan, let's just say that we add Germany and Indonesia, right, into the spreaded object, right? So we're spreading out country pop, which is going to spread out these 3 key value pairs, which Germany is a part of. And then we're saying add Indonesia, but then we're saying, hey, wait a minute, also add Germany. So we can't have duplicate keys inside of an object. Right? So this is actually going to overwrite any previous keys that match it above it. Okay, so in this case, we would actually end up with this object down here where Germany is 999 and then the other keys and values are untouched. And that's because effectively what's happening is we're creating this object and then we're setting Indonesia to it with 273 and then we're overriding Germany to be 999. Okay, so just be aware of that. Definitely kind of can trip you up in a lot of cases if you're not even sure what the keys are in the object. And it kind of does make a difference at the order that you do this in. So I'm just going to make a new file here. I'm just going to call this object-dupes.js. I'm actually just going to copy my country pop object over just for sake of time, and it's a good example. I'm going to create a const country pop copy, and I'm going to spread out country pop, right? And I'm going to add, what was it? Let's do Indonesia of 273. Oops, Indonesia of 273. There we go. And I'm actually going to add, let's just say Germany again of 999. Okay. So if I log out country pop copy, let's take a look at what we get. So I'm going to run node and object-dupes. And if you take a look at this, Germany is still the first item. However, we've actually overwritten 83 to be 999. Okay, so be really aware of this. Be careful because maybe you didn't realize, maybe this object's really, really big, for example. Maybe there's hundreds of countries in there and you accidentally overwrite one of the values. Okay, if I move country of Germany of 999 to the top here, then spread out country pop, and then add a new key. Let's take a look if that makes any difference. So in this case, you can see that it actually keeps the original value, right? Because we're kind of doing the reverse in this case. We're setting 999 first, then we're spreading out these values. And since Germany is already in there with 999, it actually gets overwritten from the 999 to the 83. Okay, and since Indonesia is not a copy, we don't actually have to worry about that, and that gets added normally as well. So very similar to arrays, we can kind of add them before and after, but the difference is arrays allow duplicates. Objects do not if it's the same key name. So things are going to get overwritten depending on where they kind of flow inside of this object spread. So just be aware of that. All right. Now, I want to kind of wrap up this video by kind of going through a pretty tricky concept, which is called shallow copies. Now, inevitably, when you're doing these copies with objects and arrays, it's going to kind of work pretty well, 95% of the time. However, there's going to be cases where you're going to run into issues. So let me show you what I mean. This is a concept that's actually pretty deep, so we're going to have to explore it in more depth in future videos as well. But I just want to kind of show you at a cursory level kind of what's happening and go through an example. So with this array right here, we have an array of prices, but notice that differently from our original array right here, where each value itself was just a number, in this example, each value inside the original array is an array with that number inside of it. So this is actually a two-dimensional array, right? An array of arrays, even though each item in that array is just one value for now. We could technically take this inner array and add multiple numbers to it, and that would be totally valid. So if we spread out prices, we will actually get a copy of prices, but it turns out that the copies only work for primitive types. Okay, so I'm going to say that one more time. When we're doing copies inside of the spread operator in JavaScript, we are only making copies of primitive types. We are not making copies of reference types like objects and arrays and other objects, or other things like, say, maps or sets and things like that. Okay. So to show you what I mean here, if we take the first item inside of prices after we've made a copy, okay, if we take prices, which is the original array, and the first item is this array with 10 in it, and we push 15 onto it, that means we'll have 10 and 15. If we log out prices, we'll see what we expect, right? 10 and 15 inside of the first array, inside of that array. But if we also log out the copy, right, it has also been modified. Now, we went through in the array video in depth how the layout of these values works inside of memory, and that will really help clear out a lot of this, because that's exactly what's happening. We're just manipulating references. We're not actually copying the entire array from memory to a new location, because some of these arrays might be hundreds or thousands of elements long, or even millions in some cases. So we should never assume, or JavaScript is definitely not going to assume, that we want copies of those things. It's just going to pass references to anything that's an array or an object or another reference type. Okay, so arrays, objects, and other reference types do not get copied when we're using the spread operator. Super important. This is going to definitely bite us several times until we get really used to it. Okay. So definitely kind of look at this slide, try to make sure it makes sense to you, and I'll go through an example really quick right now. So if I say array-shallow.js, and I'll say const prices, let's just say that in here I have 10, and I have 20, and then I have 30. Let's go with a really simple example. If I want to spread this out, so I'll console log out prices first, sorry. But if I want to spread out prices, I'll say copy is equal to an array, right? And I want to spread out prices, okay? And I'll console.log out the copy. Now this is going to look like it works, right? And if I run node array shallow, it looks like it works, right? We have our two different arrays. We have prices, and then we have copy. Okay. So where we're going to get really tripped up here is that these inner arrays are actually not copies. These are just references to the same memory locations for those inner arrays. Okay, they only exist one time inside our computer. This is to save memory, computation, and many other things. So if I take this original array, so after we've made the copy and console log that out, I'm just going to do a console.log here, and I'll just say like kind of a bunch of dashes just so that we can see that we've kind of created the copies and everything's fine and dandy. If I say prices, and I take the first item in prices, which is this array with 10 in it, right? And I pop it, right? Which means I remove the last item inside of that array. Since there's only one item in there, it's actually just going to remove the 10 and we're going to have an empty array, right? So if I console.log out prices, what we expect to see is an empty array and then 20 and 30 in arrays, right? And we do, right? And that's because I changed prices. Okay, so keep in mind, I never change copy. There's nothing about copy here after kind of this line, right? I haven't changed copy. But if I console.log out copy, take a look at what happens. Copy has also been changed, right? I never popped from copy, but it has been manipulated, and now that 10 is gone from copy as well. And this is what I mean by a shallow copy. Okay, and this goes deeper if we had arrays and then arrays and arrays, or objects and arrays, right? This goes really deep. Anything past that first level, if it's an array or an object or another reference type, if it's not a primitive type, it's not going to be a copy, it's going to be a reference. Only the primitive types are going to be actually copied. Okay, perfect. So hopefully that helps a little bit kind of with how that works. And I don't expect this to kind of make perfect sense at the very beginning. If it does, that's great. But we're going to see this come up again and again, and I'll mention it as we're actually using this in practice to build some applications. Now, the last thing I want to show is kind of this exact concept, but shallow copies with objects. Okay, so check this out. If we have our country pop object, but then we nest an object inside of it. So one of the keys now is going to be Canada, and it's going to be a value that itself is an object with a pop key and 38. Okay, so this one is special, it's different from all the other ones. It's not just a primitive number linked to a string as a key. Okay, this is an object value for a string as a key. So we can spread out the country pop object into, say, country pop copy, for example, and then country pop.canada.capital. If we set it to Ottawa, so we're adding a new key to this object, but not to the copy, right? If we try to access Canada and take a look at what's in there in the copy, we're actually going to see that it does have Ottawa in there, even though we never did anything to it. So let me show you an example here as well, just so that we can really hammer this home and you can kind of see what's happening with some commentary. So if I say, I'm just going to copy my object right here from my country pop, just so I have something to work with. And I'll also add Canada in here. But Canada is going to be an object. Okay, that's the difference. And the pop, we'll say, is 38. Okay, I think that's what I had, right? So if I say const country pop copy is equal to, and I'm going to use the object literal to spread this out into a new object, right? This is not an array. I'm spreading out an object because this is key value pairs, right? So I want it to be spread up into key value pairs as an object. I'm going to spread out country pop. Okay, so if I console.log out both country pop as well as country pop copy, let's take a look at what we get. So if I run node and object dash shallow, what we'll see is we have two of the exact same object, right? So that's great. So let me just do a console log again here, just so that you can see that now is where we're going to be manipulating this. So if I take the original object, right, country pop, and then I say, take the Canada key, right, which is an object, and now I want to add a new key value pair to this. I can do this a few ways, and I can use a dot syntax here. I'll just say dot capital. This is the same thing as using square brackets and then capital as a string. And then the capital of Canada is Ottawa, right? And now if I console.log out our country pop, let's take a look at what we get. Okay, so you can see that originally country pop was this, right? And now it has been changed to be this value. So that object that Canada is pointing to inside of the country pop object, the value is now this object with a extra key added, which is capital, which is pointing to Ottawa. But take a look at this. If I also log out country pop copy, it's going to also have been changed. Even though I never added Ottawa to country pop copy, I only added it to country pop. You can see that both of them now are pointing to the same object in memory that has both the population as well as that new capital key, because this object that has been kind of moved into country pop copy is just a reference to that point in memory. And we looked at this inside of the object video, very similar to the array video. So to save space and memory and compute, we're not going to copy all the keys and values into a new object. We're actually going to just point at the existing object. So there's actually only one of these objects inside of memory, and Canada in both country pop and country pop copy are pointing to that same object. So if we change it, we're changing it kind of in both of these places. Okay. So this is the idea of a shallow copy in JavaScript. You'll probably see that term happen or pop up quite a lot. This is in contrast to the idea of, you can probably imagine a deep copy, which is the opposite of this, which actually does take copies of absolutely everything inside of these objects and arrays. No matter how deeply nested they are, we'll actually get copies. Okay, but that's not the default behavior because it's very, very inefficient to actually do that. So to save time and space and energy and compute, JavaScript does not assume that and goes with kind of passing things by reference like this. Okay, but primitive types are still copied over as we would expect. So to get more practice with this, what we're going to do in the next video is going to go over a bunch of exercises with this. Some of them are quite tricky. So if you'd like more practice, definitely join me in that video. And if you found this video valuable, I'd love it if you could like the video and subscribe to the channel. I'd love to hear in the comments kind of what you think of this concept. Do you like using the spread syntax? Do you actually prefer not using it? Have you seen it kind of used in these kind of weird ways with kind of unexpected behavior? Does this help a little bit for you? And I'm really excited to actually get to the exercises because I have a few tricky ones in there for us, as we're going to see kind of in real life as we do web development and other things with JavaScript. So I'm super excited for that video. I'll see you in that one.